All right, guys, I got my mic fixed and now I'm recording this video again. This is going to go fast because I've already done this 3 times, even though you don't know that yet. Welcome to Math 8 1.03 scatter plots, guys. Well, clearly this is a recording, so it's being recorded. All right, let's have a go here at this warm up. I'm going to read it to you and then I want you to go ahead and pause this audio and try it on your own, and then we'll go through it, replay the audio, and we will go through it together. All right, guys, what we have here is a two-way table that shows the results of a survey where participants were asked if they own a pet and if they own a home. Fill in the missing information and use the results to answer questions 1 and 2. All right, guys, what we have here is the two-way table shows the results of a survey where participants were asked if they own a pet and if they own a home. Fill in the missing information and use the results to answer questions 1 and 2. Question 1, of those who own a pet, how many more own a home than those who do not own a home? And then number 2, of those surveyed, find the relative frequency of those who owned a pet. All right, let's start off with finishing out this chart. We have all the information we need here to do so. So let me go ahead and grab my pen. And first we need to calculate right here who does not own a pet. So out of homeowners, who does not own a pet? To find this, we simply take our total, which is 112. 112, and from that we're going to subtract the total number of pet owners, which is 76, and that will give us the total number of people who own homes but do not own a pet. So 112 minus 76 gives us 36. Now the next piece of information that we need to find here is this one. Of those who do not own a home, who owns a pet? And we have all the information we need to find this one here because, see, we have our totals of who owns a pet and who does not own a pet, as well as our totals of who owns a home, and we will find and discover who does not own a home. All right, on this one first. Owns a pet but does not own a home. The way we find that is we take our total number of homeowners, subtract our total number of pet owners, and we subtract our total number of homeowners, and we'll find our non-home owner pet parents. All right, so I'm going to take 94, and from that I'm going to subtract 76, and I will get the total number of people who own a pet but do not own a home. So 94 minus 76 gives me a total of 18. All right, now we're getting some good information to fill in the other side of our chart over here. We want to find out how many people do not own a home that were surveyed. So to find that, we're going to add our pet owners plus our non-pet owners equals our total number of non-homeowners. So I have 18. And to that, I'm going to add 70. And when I go 18 plus 70, that gives me 88 total renters, non-home owners. All right, now if we did this all correctly, then our total over here that will end up in this box should equal our total here that will also end up in this box. So 94 plus 106 better be the same as 112 plus 88 to give us our total number of people surveyed in all. So let's add those together. 112 plus 88, 112 plus 88, that is indeed 200. Yeah, step 1 is done. Now let's go 94 plus 106. 94 plus 106, and guess what that is? It's also 200. Woohoo! So there were a total of 200 people surveyed all together. All right, let's go up and answer question number 1 right there. That is a messy arrow. We will live. All right. Of those who own a pet, how many own a home? How many more own a home than those who do not own a home? So owns a pet, owns a home, 76. Does not own a home, 18. We want to know how many more pet owners there are, so we're going to subtract. So we go 76 minus 18 gives us a difference of 58. There are 58 more people that own a home and a pet than do not own a home and have a pet. All right, now let's look down here. Of those surveyed, find the relative frequency of those who own a pet. Remember, so to find that relative frequency, we take our part and we put it over our total. We just need to be sure to choose the correct total here because we have two total lines, okay? So we're talking about owners of pets. Owns a pet. Owns a pet. Okay, so of those surveyed, find the relative frequency of those who own a pet. Well, actually, we're going to be talking totals down here, okay? Because we're just talking about pet owners, and our total number of pet owners is 94. That would be our part. So it goes on top of our fraction. Under that, we put our total. For that, we want the total number surveyed. The total number surveyed is 200. So 94 people who own a pet, over 200 total surveyed. First thing we need to do is turn this into a decimal. So I'm going to read this as division in disguise. 94 divided by 200. We'll end up with a decimal because we're taking a smaller number and dividing it by a bigger number. 94 divided by 200 gives us 0.47. All right, some of you may be already able to see the answer, but for those who don't, if you don't recall, we now need to turn this into a percentage. And to do that, I'm going to bump my decimal point over 2 spaces, and then I'm going to add in that the percentage sign. So 0.47 equals 47%. That would be answer choice A. All right, so moving forward in this PowerPoint, we are going to talk about creating scatter plots. And creating scatter plots is all about just plotting ordered pairs. All right, first let's take a look at what is a scatter plot. What is a scatter plot? It's a graph of plotted points that show a relationship between two sets of data. Input-output tables, anyone? All right, go ahead and take a break. I want you to watch this video right here. Just click this link and it'll take you right to the video. It's a short one, but she is going to describe scatter plots. All right, so let's take a look at this first example here. Use the data table relating variable A and variable B to create a scatter plot. So first let's look at our data table. This looks a heck of a lot like an input-output table to me, where we have our x's on one side and our y's on the other. The only difference here is rather than being like that function machine we talked about in last semester, this is going to be just sets of data. There is no input and output, but it's just a data set of x's and a data set of y's. Now we do need to confirm that variable A is our x terms and variable B is our y terms. We could do that pretty simply. If I look at my x line here, it says variable A, that's good to go. And if I look at my y line here, it says variable B. So that is also good to go. That means that all of these data sets, these are ordered pairs. So we're going to do the first 3 of these, and then I'm going to leave you guys to plot the rest of them. But remember, when we're plotting points on our coordinate plane, we go first x, then y, because first you run, then you fly. All right, let's go ahead and do this. We're going to plot this first point here, 120, and then we'll plot 219, and then 318. All right, so first I have 120, so I find the 1 on my x line, and I go up to 20 on the y line. So my first point will be right there. Second, we are going to take a look at 219. So I go 2 on my x line, 19 on my y line. Now don't worry that there's no 19 here. We just go smack in the middle of 18 and 20. That'll give us where 19 should be. And then finally, I'm going to plot 318. So I'm going to go 3 on the x line and then up to 18 on the y. Now, this may be looking kind of linear to you, but it is a representation of variable A versus variable B. And we're going to get more into those trend lines or linear models in a minute. All right, go ahead and try to plot the data for year versus population. I'll show you the answer on the next slide in the slideshow. All right, let's go ahead and plot this one together. This one is dealing with elevation in the hundreds. We'll talk about what that means in a second, represented in meters, and then temperature in degrees Celsius. So first, what does this mean? Elevation in hundreds. Well, what that means is that these 5, 6, 7, 8, 9 actually represent 500, 600, 700, 800, 900, because we're talking about the elevation in meters, or how high in the sky these this mountain range here is, as and how that relates to the temperature. So you could see here, as elevation goes up, temperature goes down. And we should see that on our scatter plot. So let's go ahead and let's plot these points. So first I want to confirm that elevation is my X and temperature is my Y. So I could just turn these right into ordered pairs. And if I look down here, I have elevation on my X line and temperature on the Y. So that is perfect. That is where we want to be. So these are all ordered pairs, 5, 19, 6, 18, so on and so forth. Let's plot them. All right, first is 519, so I go to 5 on my X line and then up to 19 on the Y. So my first point will be right there. I lost my place. And then our next one will be 6 and 18. Followed by 7 and 14. So 7 and 14. Then we're going to go up to 8 and 10. And then you'll see here there isn't any sort of temperature drop between 800 and 900 meters because they're both 10 degrees Celsius. And that's it. That's our scatter plot. We have scattered this data on a scattered plot. Now, my dots are a little messy there, but we will live. Let me just fill those guys in. There we go. Okay, I didn't really help that second one. That's all right. All right, guys, we have pretty much the same deal here. Again, use this data to create a scatter plot. We have students' height in inches compared to their test scores. That is an interesting thing to scatter plot for, but let's do it. All right, so we have students' height in inches. We want to make sure that that is our X line because that's where our X's are, hopefully. So height in inches, perfect. Test scores should be our Y line. Let me get a Y in there and then we'll confirm it. Test scores, Y line, perfect. So we're just, for the sake of time, I'm just going to plot the first 3. I'm going to let you guys plot the second 2. So if we look here, we turn these all into ordered pairs, X then Y, because first you run, then you fly. All right, let's do this. Our first one is going to be student's height, 35 inches. 35 inches. Test score, 60. Test score, 60. Let me make sure I'm on my 35 line right there. The second one, student's height 40 inches, test score 75. Test score 75. And then finally, student height 45 inches, test score 90. Wow, that 45-inch student did really great, didn't they? 90. You know what? Let's go ahead and plot the other 2. This isn't taking very long. Height 50, test score 65. And height 55, test score 85. So the type of data that a scatter plot can show us is if there's a correlation between 2 things. Now, nobody would think there would be any sort of correlation between a student's height and their test scores. I mean, pro tip, there's really not. But there is in this made-up question. We can see here, in general, we can see a trend of scores increasing as the student's height increases. So I wonder those 60-inch students, they probably get hundreds, right? But there's really no way to know because this is just random data. All right, guys, and I'm going to leave this one for you to practice on your own. You're going to use this data to create a scatter plot of time in hours versus temperature in degrees Celsius. What happens to the temperature as the time increases? All right, guys, and that is it. We are done. Go ahead and be sure to complete all of your Unit 1 Lesson 3 components. And you guys also have that 1.02 quiz, 1.02, the quiz from yesterday. Its due date was set for today, so you guys have an extra day to get that done. So do it, do it, do it. Quiz, quiz. Don't forget that. It's going to auto zero tonight if you don't do it today. Let me know. Call me, email me, text me if you have any questions, comments, or concerns. I'm going to be around all day. I'll be in professional development meetings, and I do have a one-on-one meeting at 11:30. So if I don't get back to you, expect me to get back to you around noon, okay? If you guys are stuck, if you're struggling, send me screenshots. No worries. We could even set up a one-on-one this afternoon if you need it. All right, guys. I will see you tomorrow. Have a beautiful rest of your day. Bye.